So, hello everyone, myself D. Mohit Chaudhary, and today we are going to discuss some things about linear regression, especially in business analytics. Okay, so first of all, when we talk about linear regression, it is a machine learning algorithm where we try to fit a straight line. We find the equation of a straight line that will fit best to the given sample data, and in this case training data, and that equation algebraically describes the relation between two variables. The best fitting line is called a regular regression line, and its equation is called the regression equation. Okay, so now about simple linear regression. Now what is regression equation? The regression equation gives a collection of when we are given a collection of paired sample data, then the regression equation is an equation that algebraically describes the relation between two variables, that is x and y. So here y cap equal to b0 plus b1x. The regression equation attempts to describe a relation between two variables, and inherently the equation algebraically describes how the values of one variable are associated with the values of other variable. And we have the regression line, the graph of the regression equation. This is also known as line of best fit or the least square line. A regression line fits the sample points best. And next we talk about the notation. Here we use a notation where here one of the notations is beta and another one is b. Here, when it comes to beta, we use it in the case of population parameters, in especially in the regression case, and here it is a sample statistic one. Here, y cap e means is the sample regression equation. In the sample regression equation, the y cap is the output that we are trying to predict. So here, this equation describes the real output, and this one is the predicted one which we are predicting. So we are predicting the values for y based upon true and observed values of x. And what are the requirements for simple linear regression? A sample of paired data is a simple random sample of quantitative data. The pairs of data x and y have a bivariate ordinal distribution, meaning the following. The visual examination of the scatter plots confirms that sample points follow an approximately straight line. Because results can be strongly affected by the presence of outliers, any outliers should be removed if they are known to be errors. So now if we talk about the formulas, then we have two parameters b0 and b1. b1 equal to r into sy by sx, where sy by si and sx are the standard deviations of x values and y values, and the intercept b0 equal to y bar minus b1 into x bar. And these are generally the equations that we need to keep in mind, and when you are creating a model, then the software will automatically calculate these coefficients for you. So we just need to know this. And here is an example. Here x is the shoe print length and y is the height. So we are using shoe print length to predict a variable called height. Okay, now we have an example. What should we do to check the requirements? The data are assumed to be a simple random sample, and scatter plots show a roughly straight line pattern, and there are no outliers. And this is another example, and we are displaying the regression equation, and 125 and 173 are the parameters that we obtain, and this is the regression equation on the scatter plot. This y bar is the equation that will give us the relation, the main regression equation. Okay, so what should we do now? We will use the regression equation for predictions. We will use the regression equation for predictions only if the graph of the regression line on the scatter plot confirms that line fits the points reasonably well. And we'll use the equation for predictions only if the data used for prediction does not go much beyond the scope of the available sample data, and we will use the equation for prediction only if R indicates that there is a giant linear correlation indicated between the two variables x and y. And this is one we need to keep in mind. If the regression equation does not appear to be useful for predictions, the best predicted value of a y variable is its point estimate. Okay. Now, what are the strategy for prediction of values of y? Now, is the regression equation a good model? The regression line graphed in scatter plot shows that line fits the points where R indicates that there is a linear correlation. The prediction is not much beyond the scope of available sample data. Now, if these three conditions are a yes, then we can go forward and say that the regression equation is a good model. Otherwise, we will say that the regression equation is not a good model. Now, regardless of the values of x, the best predicted values of y is the value of y. I mean the mean of the y values, y bar. Now, marginal charge. Marginal charge is in working with two variables related by a regression equation. The marginal change in a variable is the amount the variable changes when other variables changes exactly by 1 unit. And the slope b1 in the regression equation is the marginal change in y when x changes by 1 unit. Okay. And here we have an example. For the 40 pairs of shoe print lengths and heights, the regression equation was y bar equal to 80.9 plus 3.22x. The slope of 3.22 tells that if we increase the shoe print length by 1 centimeter, the predicted height of a person increases by 3.22 meters. Now, we need to talk about statistical graphs. Now, the scatter plot is a plot of paired xy quantitative data with a dot representing each pair of points. It is helpful in determining whether there is a relationship between two variables. Here is one example. And scatter plot is very useful when we are trying to evaluate the line that fits the data. Now, the time series graph. The qualitative data collected over time and plotted accordingly with the horizontal axis representing some measure on time. So, on one axis we will have time, whichever units, and the other side we will on the y side we have a variable that we are trying to forecast. Background definitions and concepts. Now, outlier in a scatter plot, an outlier is a point lying far away from the other data points, and the inflection point is a point that strongly affects the graph of the regression line. Now we'll understand through an example. For the 40 pairs of shoe prints and heights, observe what patterns if we include this additional data point. What happens? Now x equal to 35 and y equal to 25 centimeter. Okay. Now original shoe print and height data, and now after this, adding this one point, then this is the shoe print and height data with the additional point. Here is a point. So the line will change very dramatically. So these are the points, outlier points, which we need to avoid really good. The additional point is an influential point because the graph of the regression line did change considerably. The additional point is also an outlier because it is far from other points. Now, residual and least squares property. Residual for a pair of sample x and y values, the difference between the observed sample value of y, a true value observed, and the y value that is predicted by using regression equation, y cap, is the residual equal to observed minus predicted, which is equal to y minus y bar. A residual represents a type of inherent prediction error. The regression equation does not typically pass through all observed data values that we have. The least squares property is a straight line satisfies this property if the sum of the squares is the residual is the smallest sum possible. So this is the residual when generally calculated. I mean, it is the distance from the true data points from the given line. So this is the error that we should try to minimize. Now the residual plot is a scatter plot of x and y values after each of the y values has been replaced by a residual value of y minus y bar, sorry, y cap. So I think these are the ones that we need to focus on. These are the more than enough examples to convey the point. And yeah, thank you for viewing it.